All right, so what's happening here? I skipped a bunch of stuff. Maybe I shouldn't have, but it seemed like this was a little bit overdone. So I skipped down to a couple more wheel practices at the bottom of that page. Feel free to try the other ones and I will help you out with them if you need it, but I don't think you're going to need that for the test. So I know that the circumference is the pi times the diameter. So what I did here is we have a diameter of 30 inches, which means that it's 30 pi inches. It goes 30 pi inches in one revolution, right? 30 pi is the circumference once around, so it's going to be a little bit over 90 inches for one revolution. And then what I'm trying to find out here is you always have to look at what is the question asking you to do. How many revolutions will the wheel make as the bicycle travels a distance of 3 miles? So I'm not going to answer that question first, but what I would like to answer is how many revolutions it goes per mile. And I can answer that, and then I can just multiply that by 3, right? So I have 30 inches for one revolution. I know that 1 foot is 12 inches. There's that dimensional analysis so that I can cancel out my inches. And then I know that 1 foot is 5,280 feet in 1 mile. So now I have miles per revolution, which is actually going to be weird. I'm going to flip these all over, you guys. I'm going to flip these all over because I want revolutions per mile. That'll give me a better number. Just to be clear, both of those would be correct, but it would be, all will have to do is multiply it by 3 if I do it the other way. So let's start with revolutions. 1 revolution is 30 pi inches, right? And then we're gonna change those. Here we have 12 inches. Can you hear my dog? 12 inches for 1 foot, and I'm changing it to feet first only because that's the conversion I know in my head because of 5280. So 5280 in 1 mile. So now, so you can see what I did here. I wanted feet, and this is feet. I wanted revolutions for 1 mile, so I could just multiply that by 3. So what I have is on the numerator, 12 times 5280 all over 30 pi, which I'm just going to put that in the calculadora, and parenthesis 12 times 5280 parenthesis divided by 30 pi. Cool, so 672.27 approximately. I just said it and I forgot. 672.27. 672.27. Make that approximately. Revolutions in 1 mile. So how many revolutions will the wheel make as the bicycle travels 3 miles? So all I have to do is multiply that number by 3, which is approximately 201681. So approximately 201681 revolutions in 3 miles. Okay. A bicycle wheel has a diameter of 30 inches. I wonder if that's like normal for most. That's like a yard. Is that true? It seems like a big wheel. If the bicycle is traveling at 12 miles per hour, what is the angular speed of his wheels in radians per second? So again, we want to figure out what we get. So we want radians on the numerator eventually and seconds on the denominator. All right, here you go, guys. So we have, we know that 1 revolution of the wheel is the circumference, which is 30 pi inches, the same as before. And we know that 2 pi radians is also 1 revolution. So what I have solved for, this will give you, this is kind of blank, this will give you 2 pi on the numerator and radians, and 30 pi inches. So we have radians per inches, or radians per inches. So this is going to give us 1 radian is equal to 15 inches, okay? So 1 radian is equal to 15 inches. So write that down. I wrote it down up here, and I'm going to erase this because now we want to change, we have radians, but we need to figure out in 12 miles per hour how many seconds that is, because we want radians per second. So let's do these. This is how I did it. I did it in 2 different pieces because it gave me 2 different pieces of information. You could do it in one long one. But the next thing I want to do is change, if it's 12 miles for 1 hour, okay, how many miles per second is that? So I know that 1 hour is 60 minutes. Oops, did that backwards. They need to cancel. 1 hour is 60 minutes, and 1 minute is 60 seconds. So that is equal to, my numerator is 12 miles per 3,600 seconds, which reduces down to 1 mile every 360 seconds. And I already know that 1 radian is 15 inches. So I have radians and I have seconds, but I need to change my inches to miles, right? So now, because I want radians per second, that's what I want, is radians per second. So I have these 2 things I need to change. So I know that 1 radian is 15 inches. And in this problem, so I have radians on the numerator, which is what I want, but I need seconds on the denominator. And I know that 1 mile takes 360 seconds. So I just need to cancel out all of these other things. So to cancel out my inches, I know that there is 12 inches in 1 foot. Okay, that will cancel out my inches. Remember, all I want to have left is radians and seconds. So I have to figure out how to get rid of all of these other things. And I know that there are, check those out, 5,280 feet in 1 mile, which that also cancels my miles out. So when I do this math, which is my numerator is 12 times 5,280, and my denominator is 15 times 360, when I do this math, it will give me radians per second. So let's do that math. Let's see. Parenthesis, 12 times 5,280, parenthesis, divided by, whoops, parenthesis, divided by, parenthesis, 15 times 360, parenthesis. All right, so I get approximately 11.733 forever. Radians per second. Word, like we could have done that as one big thing, but I just took what I did, you guys, the way my brain worked is I took this first part and changed it so I had radians, and then I took this second part and changed it so that I had seconds, and then took those two things and changed it so that I had radians per second. I think we have enough time for one more on this video. Let's see what's next. Okay. Describe the function graphed below. Include intervals where the function is increasing, decreasing, concave up, and concave down. State the locations of any extrema. Okay. So here is my function is increasing here. So it is increasing from negative infinity to -4. Okay, and it is also increasing from -1 to +2, and from -1 to, and I shouldn't have put 2 there, that should have been a comma, to +2. Okay, so 2 places it's increasing. Where is it decreasing? It's decreasing from, let's change the color. It's decreasing from -4 to, so from -4 to -1, and +2 to +infinity. So -4 to -1, and I need to make the and symbol, and what was I saying? +2 to +infinity. That's where it is. That's an infinity. That's where it's decreasing. And there is one like this. So we got where the function is increasing. We got where the function is decreasing. Where is it concave up? Actually, let's do this with blue. Where is it concave up? Well, let's see. It is concave up from -4 to +2, right? So from -4, it is concave up from -4 here to +2. Concave up. Where is it concave down? Well, it is concave down in 2 different places. It is concave down in from -infinity to -2, and it is concave down from -2 to infinity, or 0, I'm sorry, no, -1 to +infinity. That's where it is concave down. Okay, state the locations of any extrema. I need one more color here. So we have extrema here, because that's I wonder if white would work. No. We have extrema there, because it is a local maximum, local minimum, local maximum. So those are our extrema. And that's about it. Increasing, decreasing, concave down, concave up, and local extrema.